Hi there, this is Ajit. Welcome to Step by Step Data Science tutorial. So today we are in part 12 and we will start with k-means clustering, and we will write all machine learning equations for k-means clustering from scratch, and we will visualize the output. So I will be using Ng Coursera dataset, and we will write all the equations from scratch. Okay, so let's start. So what is k-means clustering? So k-means clustering is unsupervised machine learning algorithm. So unsupervised machine learning means unlabeled data. Unlabeled data means we don't have any output. Why? No, no output. Why? Also, it is called if we have a data set, and our goal in unsupervised learning would be to find some structure in our data. So if we can find some structures or some cluster in our data, then that is called unsupervised machine learning. Okay, so one of the popular algorithm for unsupervised machine learning is k-means clustering, and k-means clustering is explained through a visualization. Let's say this is my cluster of data here. So this is my cluster of data. So what would be the steps for analyzing k-means clustering would be, we will initialize 2 points. So here, looking at this cluster of this data, we can say that we can cluster this data into two groups, right? One would be this group, okay? Another will be this group, which means my cluster is 2, which means my k is 2. K is denoted as cluster. Okay, so how we implement k-means clustering is we initiate 2 points randomly. Okay, so let's initiate 2 points. So let me initiate 2 points randomly. One point may be here and another point may be here. So what this point is called? This point is called cluster centroid. Okay, so this is also called cluster centroid. Okay, so k-means clustering involves two steps, many two steps. So one is cluster assignment and another is move centroid. Okay, cluster assignment and move centroid. What cluster assignment means? So based on my two random points which I have initiated, based on my two random cluster centroid which I have initiated, the k-means cluster what does is it looks for closest distance. Okay, so for closest distance for this cluster centroid is this point. So I have highlighted that in red. So closest to this is this point highlighted in red. The closest to blue is this point highlighted in blue. Closest to this centroid is this point highlighted in blue. Okay, so k-means clustering does is it looks for minimum distance. So it works on it it works on taking x minus, so this is my x minus mu j, mu k. So mu k is my number of cluster. Mu k is equals to cluster number of cluster centroid. Okay, so here my cluster centroid is 2. Okay, so it so this xi is my initial data point xi. Okay, so x minus mu j, which is number of cluster point, and the minimum distance whatever we have, that would be my one cluster centroid. Okay, so this is how we assign the cluster. So based on the cluster centroid, whatever the nearest data we have, we we group that data into one. So let's say this would be my one data set and this would be my another data set. And the second part is move centroid. Move centroid means, so once we take a minimum distance, then again my cluster centroid changes. So minimum distance, if I take my center, let's say by taking minimum distance, my cluster centroid it now is here. This is my second iteration. Okay, and here. Okay, And again we iterate. This is my second iteration. So in third iteration, finally we find a point in my data where I don't need to move my centroid, and this would be my convergence point. This will be my one cluster, and this will be my another cluster. Here my algorithm converges. So this is how my algorithm will work. So k-means algorithm works on two main principles. As I said, first one is cluster assignment. In cluster assignment, we take minimum of xi minus mu k. Mu k is, this is my number of cluster centroid, and we do whole square and we take minimum distance. And the second one is move centroid, and the minimum distance that we have taken, we take the average of that minimum distance. Okay, suppose my minimum distance of one is, let's say my minimum index I have got is 2, and then the one is suppose 2. Again I got another row again. So what average it does is, one, it takes 1 by 3, 2 plus 2 plus 2. So 6 by 3 is my, so my minimum point will again become 2. Okay, so it works on this mainly on two two methods. One is cluster assignment, another is move centroid point. Okay, now we will implement this using Coursera dataset. So this is the dataset you can find in machine learning course. So let's plot this data first. So let's x comma 0, so comma 1. So x has 2 points, 0 and 1, and let's do it by 0. So here we can clearly see that we have 3 clusters, right? So now we will write machine learning equation, which is cluster assignment and move centroid, and we will see where my cluster centroid converges. Okay, so my formula is this xi minus mu j, where mu j is my number of cluster centroid. Okay, so let's create a class first. So my class k means priority self comma key, and self dot k is again k, capital K. So my one function would be to find closest centroid. Okay. So x comma, this is the one that I will randomly initiate. So centroid will be my one random initiation. First thing we need to do is randomly initiate 2 point, right? So let's initiate my two initial centroid. Let's initiate the random 2 points first. Let me see. So let's get 3 comma 3, 3 comma 3, 6 comma 2, and 8 comma 5. So right here. Okay, so we have done initiation. Initialize our 2 points, 3 points, because we can see a 3 cluster. That's why we now we have initialized our three cluster centroid. So this is my centroid. So this is a cluster centroid. So this is again the cluster centroid. This is again the center cluster. I have initiated my 3 cluster centroid. Okay, which I will pass in this centroid. So my m comma n will be x dot shape, and my key will be small k, will be my length of centroid. So for I in range of m, so I will store my result in a array. Okay, so zeros bracket 1 comma 1 comma k. So why I did 1 comma k is why I did 1 comma k here is, so what I will do now is I will calculate the distance from this point to this point, this point to this point, this point to this point. So I will store that value in my array. So I will keep three values here. So my centroid is 3. So my key will be 3, and then I will initiate then I have initiated my display data as zeros of 1 comma 3. 1 comma 3 means maybe 0 0 0. So I have initiated this 3 0 because to calculate the distance of 3 points from a centroid. Okay, so that's what my key will have 3 here. So for j in range of k, so I will store my my key will be running from 1 to 3, which will be stored in a column. That's why I did j. Then my x will be I here minus centroid of j. This minus this is my formula. Okay, and then what we need to take is we need to take whole square, which means np dot power power this comma 2. Then we will do np dot sum. So once we do sum, we need to take square root sq not square root. Now we will store this value in index equals np dot zeros. My index will have data from all the data that I have in my x variable. So my idx dot, let's print the display data, and see whether we have received 3 points or not. Let's print this first. So I have initialized my centroid, and then I will create an object of my k-means, pass k as 3, and then I will call this function pass x comma initial centroid. Let's restart. Okay, so here is centroid here with a typo mistake. Okay, now we can see 3 points. So this 3 is the distance. So like I said, these 3 points I have got for 3 cluster. Okay, so this is what we got, 3 distance. So one is my 1.98, 0 and 0. Now we need to take the minimum. Okay, minimum of this value. Let's print out the minimum index even. So np.argmin minimum of this we will take. So if we run this in, so here the minimum is 1. So it starts from 0, 1 and 2. Okay, so here the minimum is 2. Here the minimum is 1. Okay, so I will store this result in my index. So my idx of I will be equal to, I will do +1 so that it starts from 1. I will assume it is starting from 1. Okay, so now let's get my index. Let's remove the print clause. We need one bracket here. Yeah, this is working. Now let's check. Okay, this is also working fine. Now I will store this in one variable, and I will print my closest centroids for the first 3 examples class idx of 0 to 3. So my first 3 closest centroids. So this is my index. Okay, so this is my index. Now what I will be doing is I will calculate the mean. Okay, so this would be my next function. Self comma I pass x and idx, which I have already calculated. So n comma n will be again will be my shape. Okay, and my centroids will be p dot zeros of self of key comma 1. Now for I range of what I need to do. So my index will be equals to index of I. So I will do -1 because I have done +1 here. So I will do -1. Convert this. I will make sure that this is my integer. And, okay. So my centroid of index will be first of my index count. So I also need count to take address. So my count will be zeros. This will be my centroid will be from k to n. Sorry, from k to n, and my count will be from k to 1. So why I did my centroid as k to n is because so I did centroid as k to n. Okay. So my k is the number of centroid. Okay, cluster centroid. cluster center, which is equals to 3, and n is my number of feature 2. So I need to have my 3 by 2 data set. Okay, why I need to have? So that I can store my minimum distance. So my minimum distance, my centroid point should have 2 axes, right? For 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 3, for k equals 3, so I need this one for k equals 3. So this point should have my x and y coordinate, right? X and y coordinate, x and y coordinate. This one I need 3 by 2. Okay, so that I can store my centroid, average of centroid, and my count of index will be plus equals 1. Okay, now I will return my centroid divided by count. So this is working fine. So k means dot minus, and pass x comma index which I have calculated. So let's rerun this. Okay, centroid will be equals. Let me check if this is correct or not. Okay, this looks good. Now we will visualize our result. So now we have got our got centroid and index. We have received cluster assignment, which is my index, and my moving centroid also I have. Now I will visualize my output. Okay? Centroid dot underscore k means bracket self, and here I will include x idx comma centroid and my number of iteration. My m comma n will be again x dot shape. Okay, now I will do a figure. It will be my data subplot. Those will be my number of iteration, and columns will be one figure size. Let's give a figure size of 6,36. Okay. And now for in range of my number of iteration, so I will color my 3 cluster which is of red, blue, and green. Okay, so for small k in range of self k, k plus 1 because 1, because the range does not include the last value, so we need to do plus 1. So let's grp group it. If my index idx is equals to small k, then receive comma 1, and my ax of I dot scatter x of comma j comma 1. So I will apply my group here, group of comma j comma 0, and my color will be, so my C will be equals to K minus 1, and my size S will be equals to 15. Okay. So what I did, guys, I will explain you. Okay, don't worry. So let me print this first and see whether my code is working or not. Okay, I will explain this to you. Don't worry. So I will pass all these metrics. So my equation will be T. So this is my centroid, IDX. So let's restart. File figure size. I don't have any space here. Sorry. Okay. So what we did is, so we group our index on basis of the cluster centroid. Okay, so this is the cluster centroid key. So for one, if it matches the index, then we will color that to one color, which is red, and again it matches to another index, then we color that to blue, and if it matches to third index, then we color our plot to green. So by doing this in 10 iteration, we see these three clusters. Okay, now we will add centroid here. So ax of I dot scatter bracket centroid of convergence centroid comma 1. So my color, let's say, keep it black. Increase the size by 150, and my marker is equals to, let's give it x. Okay, let's run this. And if we run this, then so now here we can see my 3 cluster assignment, right? So this is my 3 cluster assignment. Now what we will need to do is we need to apply our index. Okay, so my index now will be equals to this find closest centroid. So we need to apply this function. And this is index comma centroid, and my centroid will be dx. Okay, let me check if this is working or not. Let's start. So here we can see my cluster is converging. So at this point, at this iteration, my cluster is converging, right, to 3 points, 3 groups. Okay, now let's add the title even. The title will be, let's add number plus space plus str I. Title set underscore title. If we rerun this, so here we can see in first iteration my cluster centroid is here at this point. In second iteration it moved a bit to next iteration, it moves a bit this side. In second iteration it still is in the same position. In third iteration it moves a bit closer to 3 cluster. On fourth iteration it converges to 3 main cluster. And 5, 6, 7 we see it has been converged, right? So in fifth iterations we see our cluster mean is converged at 3 clusters. Okay, so this is how we visualize our k-means clustering. Okay, now what we need to do is right now we initialized our initial centroid as this value we gave this as our initial value. So we need to make sure our initial value is random. Okay, so for that we create a random function so that my initial cluster centroid is random. Instead of manually giving the input value, we will create a random function. Okay, so k means init and centroid bracket cell comma x, again m comma n will be x dot shape. So this is to create random initial cluster centroid. Okay, so mp dot zeros again be key comma the centroid will always be key comma n. This in case so not k. So for I in range of self dot k centroid of I will be equals to x of random np dot random dot identity rand int to starting from 0 to n plus 1 comma and then we return centroid. So what we did here, we that instead of giving manual initial centroid, we created a random initial centroid function. Okay, this is making sense, I think, too. To pass here is x. Now this will become my initial centroid. Instead of giving manual initial centroid, I created a random generator function that randomly generates the initial centroid. Index 300 is out of bound. Just connect. Zero to n plus 1. Index 300 is zero size. Not sure what does this mean. If we copy this, something is the same. So this is my function. Let me We run it again. Okay, it's working. So I got my initial cluster. Now my key means is 3. So my initial index will be this one. This will pass here, and then we will calculate centroid index centroid, and finally we will do visualization. So here we can see in zero iteration my 3 cluster centroids was here. In first table it was a bit separation we see into iteration. In third iteration it went here, and at fourth iteration we see it converges to 3 cluster point. Okay, so this is how we implement and visualize k-means clustering. Hope you have learned this, you have learned from this video, and you have enjoyed this lesson. So if you like my channel, please do subscribe and encourage me to create more videos. Thank you. See you next time.